My name is Yusuf Morsi, and my partners are Behrad and ISIS. And what we're doing is an ultrasonic sensor security system where we're using a HC-SR04 ultrasonic sensor. And this is for our Lab 5 project for ECE5. So as an overview, I want to explain that in this lab, you will be working with an HC-SR04 ultrasonic sensor. You'll be writing Arduino C code that will print the general distance between the sensor and an obstacle. You'll be making plots with Arduino, integrating a piezo buzzer, 3 LEDs and IR technology, integrating temperature with a thermoresistor and a HT11 humidity sensor, and you will be using Arduino. In addition to Arduino, you'll be using Autodesk Eagle and Onshape. So for challenge 1, all you'll be doing is installing a circuit that will be preparing you for the future challenges. And as you can see in the bottom left image, that mainly consists of the ultrasonic sensor, the buzzer, the LEDs, the resistors, and some wires.
For challenge 2, we'll be differentiating the LEDs on the circuit board with an alternating color code. A bright red will represent the danger zone for too close, a softer yellow when the distance detected is moderate, and a serene green when the person or entity is very far away. The Arduino C code here is graphing distance of part A completed. These values represent the general distance of the HC-SR04 ultrasonic sensor. To graph these values, go to Tools and then Serial Plotter from the drop-down menu. After you're done, move on to part B, the LED color code, and complete the same steps as before.
Hello, my name is Brad Rabi'i. In challenge 3, we're tasked with building a PCB board on EagleCAD and building a case for our circuit in challenge 1 and 2 on Onshape. As you can see, this is our final PCB, and we were able to attain all of our wire connections from the schematic using the auto router. And so now we're going to switch to the schematic.
And I'm Yusuf again, and this is our schematic, and we got the components here from uploading several different libraries from our document. To actually access something from a library, you need to press on Add Part, and from there you'll be able to access the component from the libraries you download. Challenge 4, we'll be experimenting with IR receivers and remotes, and the benefit of this edition is that now we get to decide when we want to detect the distance from an object and when not to. So we will be using an IR remote and receiver to turn our ultrasonic sensor on and off, and we will be using Ken Sheriff's IR remote Arduino library from GitHub, which will be in the document, and the timer R11 zip file, which is on Canvas. Now, as you can see on the circuit, we have an IR receiver, and that will be mainly used to detect signals from the IR remote.
For challenge 5, you will learn about capacitive sensing of air and how temperature could play a role in obstacle detection of the ultrasonic sensor security system. In part A, you will be working with an NTC thermistor. Then complete the code like so, and you will be able to see the temperature printed in Celsius, Kelvin, and Fahrenheit. For part B, you will connect the ultrasonic sensor with the HT11 humidity sensor. You want to be able to detect whether the obstacle near the HC-SR04 is a person whenever the red LED is digitally written to high or when the alarm goes off. This is the purpose of our ultrasonic sensor security system, to protect ourselves and shield ourselves from potential harm. I also have a bonus part with the IR proximity sensor here if you want to sense a person's presence with IR light. It will be able to detect cloth and softer materials too, differing from the ultrasonic sensor. In conclusion, this lab was mainly inspired by Krepak's ultrasonic sensor developed in November 2017 on Arduino's project hub page. Information about the HC-SR04 ultrasonic sensor was found from last-minute engineers, and there are other resources and references here too if you want to browse through them. This is our Lab 5 non-contact range detection of the HC-SR04. I hope you enjoy working on this lab as much as we did. Thank you.